Hello dear friends, everyone. We continue our acquaintance with the no-code BEEP Toolkit platform for the development of robotics, automation, and smart systems. In the previous, first introductory lecture, we examined simple RPA algorithms for working with the graphical interface, programming methods, and the ease of entering control instructions. Today we will look at examples of working with hardware connection of various loads. As components for switching AC and DC loads, you can take mechanical relays with control from 5 volts with optical isolation. It is important to consider their life cycle, which is significantly inferior to solid-state relays SPDT using MOSFET transistors. Modules based on MOSFET switches with optical isolation are compatible with any controllers, for all types of AC or DC loads, including PWM signals. We did not begin here to focus your attention in detail on their types and structural features. This information is available in many articles on popular sites for electronic components with recommendations in their selection. As an example, we took a control module based on a MOSFET transistor FR120N. Thanks to the inclusion of optoelectronic isolation in the circuit, the control signal and controlled equipment are protected from external interference. It is widely used to control electric motors, solenoid valves, solenoids, electromagnets, heating elements, and other power devices of various voltages and currents. In our case, the module supports the voltage of the connected DC loads in the range from 5 to 100 volts and the current up to 10 amperes, which fully corresponds to the parameters of the test bench. For loads, let's take a 12-volt DC servo motor, a 24-volt bipolar stepper motor, a 12-volt solenoid, and a powerful 12-volt LED. Schematic diagram with the distribution of components of power with direct current of 5, 12, and 24 volts. The control algorithm is as follows. After the start, we give a pre-start pause of 5 seconds. For this we use port 1 to set the time. Next, we start the servo motor. For control we use the second port and the first channel. In this case, we turn on the LED. Its control will pass through the second channel of the third port. We start the stepper motor. Fourth port and third channel. The solenoid will retract and release the moving core 5 times at 1 second intervals. For such a procedure, we will set the repetition cycle to a multiple of 10. 5 inclusions and 5 disconnections, which will be equal to 1 second. It is important to consider that 1 second should be divided between the two procedures. 500 milliseconds on and 500 off. We install this instruction through the 5th port with control a 4th channel. After completing the solenoid procedure, disconnect all loads. The shutdown procedure is performed using the 6th, 7th, and 8th ports with the same channels that were assigned to start. Let's start. Everything worked out clearly and corresponds to our algorithm. After successful simulation, saving our code in a file called prog4. In terms of complexity, a script can include a fairly large set of instructions. Along with this, there is the possibility of hardware expansion of the output channels. This turns the work with the platform into operative ideas. The seeming simplicity of working with the platform hides the high-performance work of the logical core, which we are constantly improving and optimizing. If you have any questions, ask them in the discussion or on the product forum. Links are below in the description. In the next lecture, we will look at the functions of ports by input channels, which are an integral part of any adaptive automation and robotics. Write your comments, like, register on our forum and subscribe to our channel. See you soon.